Hey guys, so in this video we're getting the last of the factoring methods. We're going to get the last three term, which is this one in the middle, which was the perfect squares on the ends. So kind of our approach then for three term problems is going to be, if it leads with a 1 in front, just a plain x squared, we're doing the thing we did in the last section. If it has perfect squares, we're going to do the thing we do in this section. And then if if both of those things fail, then we're magic method, which we saw again back in the last video. So then the other two things we get are the two-term problems, and they're either going to be squares or cubes. Those are our only choices, and how we approach each of those just depends on which one we have. So let's look at some examples. And so for this first round, we're going to do squares. And we have kind of three formulas for squares. I'm going to start on the two-term ones. I'll do the three-term ones next. So for the two terms, it goes a squared minus b squared. So if we have what's called a difference of squares, it's always going to factor to a plus b and a minus b. And the reason for that is if I multiply those out, a minus b. So if I do my FOIL, I get a squared. On the outside, I get minus ab, and then on the inside, I get plus ab. And those just drop out. And then on the end, there's the minus b squared. So pretty much every time I see something of this form, there's the factored version. So looking at this first one, oh, and the other thing I meant to say is here's a list of the perfect squares. So what we're going to do is when we see something on like a 25 on this first problem, 25 is a perfect square because 5 times 5 is 25. So we're going to see a 25, it's going to factor down to the 5s is kind of the deal. So for this first one, we got, our a squared minus b squared. And so the a plus b, a minus b is going to look like x plus 5, because x times x is x squared, a times a is a squared. Same thing with the 5, and then x minus 5. And these difference of squares are just that easy. There's nothing else to them. Once you realize that's what it is, a plus b, a minus b. So next one, 16, right? So 4 times 4 is 16, so that'll break down to a 4 with an x, because 4x times 4x gets me 16x squared. And then plus 7, because 49 is our 7s. And then 4x minus 7. So these next four are the ones that have you guys try in class. So here we got x squared minus 16, so x plus 4 and x minus 4. That one, let's see, we got a 9 and an x, because 9x gets us 81x squared, and then plus z, 9x minus c. I hadn't said yet, it doesn't matter again which order. If you go minus plus, you just need the mixed signs. This one is incredibly sneaky because 16 and 4 are both perfect squares, but 16 and 4 have a common factor of 4. So it's really easy to miss that 4 there, but we do have to take the 4 out first. And that gets me down to 4x squared minus y squared. And now I can finish factoring the inside piece as we've seen with the GCFs. So 2x plus y and 2x minus y. And this last one, so here's an example where you look at it, it doesn't have perfect squares. 50 and 98 weren't on that list. But it's got two terms, and these are squares. So it kind of tells you there's got to be a GCF in there to get out of the way, so that you can get to those squares so that you can finish factoring. So in this case, 50 is 25 times 2, so 2 is as good as that's going to get. So I'm going to pull a 2 out front, and now you can see there's the 25x squared, and then minus the 49y squared. And then I can just break those down. 2 just comes along for the ride, and this is going to go 5x plus 7y, and 5x minus 7y. So in this next round of problems, we're going to use these three-term formulas. I'm just going to take one of these down here and then kind of show why these are what they are. So if I have a plus b quantity squared, what that means, it doesn't mean a squared plus b squared. It means a plus b, a plus b. And so if I FOIL that out, I get a squared, ab on the outside, ba, which I'm going to write as ab on the inside, and b times b is b squared. So there's our 1ab, 1ab, and then that gets us that 2ab for the formula. Hopefully this is familiar because we saw it in an earlier section when we were doing the special products as FOIL. So now we're just basically having to recognize it, what would have been our answer in the last one, and then take it back to this version. And then just a reminder, the difference in them, if it's a minus in the middle, it's minus. If it's a plus in the middle, it's plus. And both are positive on the end. So let's see what that looks like in terms of these. So if I run into this problem and I'm supposed to factor it, the first thing I do is, does it lead with a 1? No, so that means the nice easy kind where we just do the x and the x is out. Does it have perfect squares on the ends? Yes. So 49 is a perfect square, r squared is a perfect square. So that means we are probably in the land of these special formulas, or special products, or trinomials. So what I do is I just kind of pretend like it's going to work, and then I check, because it's a lot easier if it works to just check it than it is to go through and do magic method on these things and then figure out it would work. So I'm just going to go, 49x squared would break down to a 7x. This is a plus, so I'm going to say plus. That's an r squared, so that would break down to an r. And that should probably be my answer. To check it, I'm going to do the 2ab thing in the middle. So remember, this middle term has to be 2 times a times b. So 2's from the formula, a is the 7x, and b is the r. So 2 times 7 is 14xr, and that is what's in the middle. So for me, when I'm kind of just double checking that I didn't dork something, or that this had squares on the ends but the middle was something sneaky and it wasn't one of these, I just take whatever's here and go, I go double it, so 2 times 7 would be 14xr. That matches my middle term. This next one, let's see, it looks like I can pull just an x squared out of there because the 81 and the 100 aren't going to play. So that's going to go 81x squared minus 180x plus 100. So, you wouldn't, if you saw this, you might start doing a magic method and getting 8100 and this giant number. And that would be way harder. Much better way to look at it is, 81's a perfect square, so is 100. I bet it's one of these things. So I'll just go 9x and then minus 10. So 81x squared breaks down to 9x, 100 breaks down to 10, and then a minus makes a minus, quantity squared. And then my check is I just go 2 from the formula, the 2ab, so 2 times 9 would be 18 times 10. There's our 180, so it is what I think it is. These next 4 would be the ones I'd have you guys try in class. So this one you could think of both as kind of the easy version where you just set up the x's and what multiplies to be 64 and adds to be negative 16, so negative 8, negative 8. Or if you saw the squares on the ends, you could think of it as, okay, x minus 8 quantity squared, 2 times 8 makes the 16 in the middle. These are the same thing, so when that's a 1, you can kind of think of it either way. This next one does not have perfect squares as it's written, so that makes me want to look at a GCF maybe, plus those are kind of big numbers. So I think we can do a 6 out of everything, so we'll pull that out front. 6 goes into 54 9 times, so 9x squared. 6 into 36 is 6x, and 6 into 6 would make 1. And so now that 6 is all taken care of, and I'm just going to work on the inside. I see a 9x squared. 1 is a perfect square. It's a boring one, but 1 times 1 is 1. So likely this is going to turn out to be 3x plus 1 quantity squared. And then all I would do again is just kind of go 3x times 1 times 2. Yep, that's my 6x. So it is what I think. Here, can't do anything with those numbers. 36, 121 won't work, but I could get an x squared out of the way. So then I have 36x squared minus 132x plus 121. And you can see if you tried to do this one by magic, it would be really a huge, terrible number. And so that's why it's nice to have this technique. 36 is a perfect square. It'll be a 6x. 121 is 11 times 11. And even if you didn't know that, be suspicious because that 36, right? I would check the 121 even if I didn't know. And then there it is. So I can go 6 times 11 would be 66, and if you double that, you'll get the 132. But so it takes this problem that would have been super hard magic method and makes it just look at it and write down the answer. Number 12, no GCFs. Does have that extra letter on the end, but not a big deal. It's just going to go 5x. That's a minus, so that's a minus. 144 is 12 squared, and then it needs the r with the square. So if I go 5 times 12, that's 60, double it for 120. And then this last round is the cube formulas. So these are all the other version of our two-term problems. And this time, so the first ones have squares on the ends, these ones will have cubes on the ends. And then here's a list of the cubes, just to kind of numbers to look out for. And I'm not going to FOIL all this out, but if you did FOIL all this out, it really will come back to this. What I want to talk about is how to get from this side to this side. And so I'll kind of do that in the course of this example. This x cubed is this a cubed, the 125z cubed is the b cubed. So what I got to do is figure out kind of the basic version, what's really a cube root. We don't know those yet, but we're thinking what times what times what would make the 8x cubed or the 125z cubed. And you know, the answer to it's kind of basically here. If you see an 8, it's 2 cubed. So that 8's going to break down to a 2, very similar to the squares we just did. So hopefully you can see right here I would have a 2x, and again it's 2x, 2x, 2x would get me back to 8x cubed. And by that same logic then, 5z, 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 because you look right there, 125 makes a 5, is going to get it back to the 125z cubed. So what that does is it gets us our a and our b. I keep pointing at this one, but it's really this one with the minus. And then we have to fill in this next part. And it's just, if you just think of it as a pattern rather than a formula, I think it's way easier. Once you have these two, you know, this is a squared, so you just have to take whatever's here and go this times this, and it goes there. So in this case, we're just saying 2x times 2x, and that's 4x squared. And then it says to go multiply them together, and that goes in the middle. So here I just go 2x times 5z, and that's a plus, and then 10xz. And then on the end, I take whatever's here and square it, so multiply by itself. So 5z times 5z is going to be plus 25z squared. So one more time on that. I'm taking this and I'm trying to figure out what times what times what gets me back here. Same thing here. Once I get these two, so breaking these down, then I just take this and go 2x times 2x, 4x squared. 2x times 5z, 10xz, 5z times 5z, 25z squared. So I am using the formula, but I'm not thinking of it as I'm plugging these things kind of mechanically in and then trying to figure out the math. I'm just kind of thinking more of a pattern that the formula makes. So the way I get around memorizing the formula is kind of the pattern, but then the part that I had trouble with was remembering the signs. So the thing I kind of figured out as a student was this first sign is always the same in both formulas. So if it's a plus, it's a plus. If it's a minus, it's a minus. So I kind of think of that one as same. And then if you look in both formulas, it goes plus to minus and then minus to plus. So opposite for that one. And then the last sign in both formulas is positive. So once I kind of realized they follow the same pattern, same opposite positive, that I seem to be able to remember, or SOP if that helps. And so that's kind of how I think of the signs. So first one matches, second one's opposite, last one's always positive. This next example is it's silly. All this is, so they put this negative 64 in front to kind of freak you out. If that was a positive 64, I would just proceed through the problem and it would be 4 and 3x. But because of that negative, and you look at the order of the formula for the negative one, the negative's second in terms of that b. So it's going to go better if you just rewrite it. Oops, there we go. That's going to turn into a 64. In the order that actually makes sense. So I'm just slipping this over onto this side, and now it looks just like the formula. So then I can break this first part down. 27 breaks down to 3 with an x along. And then my messy 64 there is going to break down to a 4. And then once I have those, remember we just do first times first, so 3x times 3x is going to be 9x squared. It was a minus, so now it's a plus. Then we multiply these two together, so that'll be a 12x, always a plus on the end, and 4 times 4 for 16. And then this next one, so 250 and 2, these are not cubes, but the x and the y are. So this is kind of telling me it's going to turn into one of these formulas, and the trouble is I just have a GCF in there I need to get out of my way. So I'll take a 2 out front. That's going to give me 125x cubed plus y cubed. And then I can take this 125 apart and make it a 5x. And then the y is just going to be a plain old y. That first sign matches. And then 5x times 5x, that's 25x squared. 5x times y, so, oops, minus, opposite sign, 5xy, and then plus y times y, y squared. Okay, and then these last 4 problems are the ones I'd have you try in class. So we'll go through these fairly quickly. This would go x plus 2, and then x times x is x squared, x times 2, so minus 2x. 2 times 2 will make a 4. This one, so we can see the cube. These aren't cubes, so there's a sneaky little 2 in there, so we'll get that out of the way. If I take out a 2, that'll be a 27x cubed, and then 2 out of that would be an 8. And now that I have the GCF out of there, I can see what I got, and then we'll do the rest. So this is going to go 3x and minus 2, and 3x times 3x would be 9x squared. 3 times 2 plus 6x, and then 2 times 2 for a 4. This one, that's that one that's written in the funny order, so I'm just going to clean that up, make it x cubed minus 1250, so then I can take a 10 out. That's going to give me x cubed minus 125, and then there's our cube. So 10's going to go there, and then x minus 5, x cubed 125 breaks down to a 5. X times x, x squared, x times 5, plus 5x, and then 5 times 5 for 25. And this last one, let's see, no GCF, so just as it is. 8x cubed will be 2x, 125y cubed will be plus 5y, and we just fill in with that. So 2x times 2x will be 4x squared, 2x times 10, so opposite sign, minus 10xy, 5y times 5y, 25y squared.